All right, so I'm going to start in 7.1. And that deals with symmetry. Okay, so there's three types of symmetry we're going to look at on our graphs. So the first type is symmetric to the y-axis. All right, so for a graph to be symmetric to the y-axis, if I fold the graph along the y-axis and the graph lands on itself, then the graph is symmetric to the y-axis. Okay, so let me show you one that would be actually symmetric to the y-axis here. So there's my x and my y. And actually, y'all, the parabolas that we've been playing with in class, parabola comes up like that on each side. So what they mean is if I took this graph and I fold it along that y-axis and the graph lands on itself, then it is definitely symmetric to that y-axis, okay? So it just depends on being able to fold that paper over and it hitting itself. So the second one would be symmetric to the x-axis. And y'all, that's the same thing as the y. On this one, what I would do is I would fold the graph across the x-axis and see if it lands on itself. So if I fold the graph along the x-axis, and the graph lands on itself, then the graph is symmetric to the x. Okay, so it's the same principle. So let me try to draw one that might be symmetric to the x. So there's my x and my y. So to be symmetric to the x, you have to have a graph that looked the same on both sides of that x. And what I would do is I would just fold this along the x-axis and watch how the graph actually comes in and lands on itself. Okay? So that was the second one, symmetric to the x. And then let's look at the third one. So y'all, number 3 would be symmetric to the origin. Now remember, the origin of the graph is that center, that 0, 0 point where the two x and y axes intersect each other. So to be symmetric to the origin is a little bit different. if I rotate the graph 180 degrees, so basically if I turn it upside down. So if I rotate the graph 180 degrees and have the same graph, then it is symmetric to the origin. All right, y'all, so these are a little trickier for me to draw, so let me see. So I'll call that my X and my Y. So to be symmetric to the origin, it's going to have to sort of come up, hit that middle, and then go back up. Now, they all won't look like this, but this is a general idea. So notice it comes uphill, left to right. If I turn my paper 180 degrees, it's the same graph going uphill, left to right. So you turn the graph upside down to check for the origin. All right, then we're going to look at what we call even and odd functions. To be an even function, the graph is symmetric to the y-axis. And then the graph crosses the x-axis an even number of times. So if it's an even function, it's going to cross the x-axis 2 times, 4 times, or even 6. It's going to be an even number. And then to be an odd function, the graph is symmetric to the origin. Okay, which means these graphs crosses the x-axis an odd number of times. Okay, so an odd function will cross that x-axis either 1 time, 3 times, 5 times, but it will be an odd number, okay? So there's 5 little problems in this section I'm going to go through, and then we'll go into 7-2. Okay, so I'm going to move this one and start some of our examples. So y'all, the first 3, we're going to determine if symmetric to the y-axis, x-axis, or the origin. Oh, and I was going to say on that even and odd, the reason that we didn't have one for the x-axis, because remember, it fails the vertical line test if it's symmetric to the x. So that's why it's not even a function. All right, so let me draw this first one here. So there's my X and my Y. All right, let me see. This one sort of does like this on the right side and goes out. And then on this side, it sort of dips down and then goes out like that. So y'all, not real good pictures, but notice, if I fold it over the Y-axis, it does not hit itself. This part hits up here. If I was to fold it over the X-axis, it would not hit itself. This would be hitting something that ain't even here. But if I take this graph and I turn it 180 degrees, I have the same graph going down here and up over here. So notice it's down on this side and up over here. When I turn it back, it's down on this side and up over here. So since it's the same graph, when you turn it upside down, this is symmetric to the origin. Now the homework will have prettier pictures than what I'm drawing, okay? All right, so number 2. I'm gonna have an X and a Y. So this one sort of comes out and shoots up that way, and then does the same thing to the other side. All right, so let's see. I fold it over the Y-axis, and look at that. Once I fold it over the Y-axis, this part hits right on top of that part, so it's definitely symmetric to the Y. It's not symmetric to the X because this part hits down here where there's not a graph. And then y'all, if you turn it 180 degrees, you do not have the same graph because our graph was going uphill on both sides. So it's only symmetric to the Y-axis. Okay, so these aren't bad. You just got to sort of look at them and think about the 3 things we're doing to them. All right, and then this last one on that. Let's see, I got an X and a Y. So this graph they got starting here, going uphill like that, and then this side's going downhill like that. All right, so let's check the Y. If I fold it over to Y, this part hits up here where there wasn't a graph. I'll check the X. If I take the top and fold it over, this top part will land right on top of that bottom part. So it's definitely symmetric to the X. And then if I turn it upside down, notice this is both pointing to the right. When I turn it upside down, they're both pointing to the left. So it's not the same graph. So it's not symmetric to the origin. So y'all, the only thing that one is symmetric to is the X axis. Okay, so let me let y'all write that real quick. All right, so the last 2 deal with even and odd. So I'm going to flip it over. So we're going to determine if even or odd. So this would be like number 4. All right, so let me draw this picture. All right, y'all, this one comes down like this on that side, and then comes down like that on the left side. So even or odd. Remember, we said if it's even, it's symmetric to the Y-axis, or it crosses the X-axis an even number of times. So this one looks like it's touching the X-axis twice, which is even. And also, if I take my graph and fold it over to Y, it lands right on itself. So this is definitely even. For that to be an odd, it would have had to be symmetric to the origin, and it would have had to touch the x-axis an odd number of times. All right, y'all, this is going to be a little trickier. It comes down here, goes up, and then comes down on that side. This side goes up, comes down here, and then goes up that way. So we'll check even first. Even would have to have an even number of times it touches the x, but this one touches 1, 2, 3, 4, 5, which is odd. So then I would check for the symmetry, and it does not land on itself, so it's definitely not even. So odd, we said this crossed how many? 5 times, which is an odd number. And then, had I drawn this really nice, once I flipped it upside down, I would notice that it would be symmetric to the origin. So since that one is symmetric to the origin, this is a odd function. All right, y'all, so any questions on that 7.1? We just wanted to look at a little symmetry to the y-axis, x-axis, and the origin, okay? So next, I will be getting into 7.2. Seven point two deals with transformations of graphs. And then I'll be doing this one on MATLAB also when I get to the actual problems, because it's tricky doing these in the MATLAB. All right, so given a function f of x. Y'all, the first thing I can do is a vertical transformation. I can move a graph up or down. So to do a vertical transformation would be f of x plus or minus b. That means I take my function and I add a number to the end, or I subtract a number from the end. Now, if the b is positive, it's going to move up. And then if that b is negative, it's going to move down. All right, second move. I can move a graph left or right. So that would be a horizontal transformation. So to do a horizontal transformation, I got to attack the x. So that f of x plus or minus a. Notice, I'm not adding it to the end of the function. I'm changing the x's in the function. Now, this is a little different than you would think. By adding a to my x, it's actually going to move my graph left. And by subtracting from my x, it's going to move my graph to the right. All right, y'all, a third shift that we'll look at in this section is a reflection across the x-axis. Now later in life, we'll reflect across the y, but that's like on the last test, I think. So to reflect across the x-axis, you just make the function negative. So whatever your function is, you change the sign in the front, and it will flip it across the x-axis. Now, there's some basic graphs they want y'all to know. Okay, so we're just going to draw some basic graphs. So the first one is the line graph. So if that was my x and my y, the basic line graph would look like this. So it would be y equals x. The second graph that's basic is our parabola. This would be y equals x squared. And we've been messing with them parabolas. Y'all graphed a few in the last section. All right, next graph. Y'all graphed some of these in the last section. These are absolute value graphs. Now they make a sharp V instead of a curvy parabola, okay? And this would be y equals the absolute value of x. All right, next basic graph. Would be, it comes uphill left and then sort of goes uphill to the right, but they slightly curve. This would be y equals x to the third. This is the cubic graph. All right, let me see what else they hit y'all with on these. You got the squares. Cubes. Squares. Oh, square roots. All righty. So I got two more I'll put on here. Now these graphs would have been in the textbook, but since y'all don't have textbooks, it might be in the ebook. When you look in 7.2, it'll have these basic graphs. All right, so the next one I'm going to do, it sort of curves slightly to the right. This would be y equals the square root of x. So like square root of 0 is 0, square root of 1 is 1. Over here, square root of 4 would be 2, and so on, okay? All right, now the last graph I'm going to give you. All right, let me think. This graph sort of, tricky to draw this one. But this graph sort of comes down right by the y-axis. And then on this side, it comes down right by the x. This is y equals 1 over x. So that'd be fractions, like, and you don't have a line going across the y-axis because remember 0 makes it undefined, so the graph cannot cross that y-axis. Now we'll play with these graphs more in the future, but that would be the basic graphs for the fractions. All right, y'all, so remember all this, keep this handy, because what I'm going to do is switch over to the math lab and show you how these homework problems are going to be done. So I'm going to share my math lab screen. All right, so we're going to continue on this. So let me move this out of the way now. All right, so notice they're giving me a function, y equals x plus 10 squared. And they want to know how that can be obtained from my basic graph. So the basic graph on this, since that's a x plus 10 squared, the basic graph would be the x squared graph because you got an exponent 2 here. But what we got to do is find out what that plus 10 is doing to the graph. So you notice that I gave you the 3 transformations. To be a vertical, this 10 would have had to been added outside of the parentheses. So this is definitely inside the parentheses with the x. So it's going to be a horizontal move. Now remember, we said if that is a positive number, if a was positive, which is 10, it's going to move left. So we want to pick the choice here that says go left, which was my A. So you're going to click that. And then we got to put in here that we're starting with the graph of x squared. So I would put my x and then come down here to do my exponent and put in my 2. All right, so I got to move this stuff out of my way here so I can reach my buttons. All right, now watch this. When you check the answer, it's going to want you to graph this. So we're going to click this to graph it because this is the tricky part on this. Since we had an x squared graph, we need to grab our parabola. Now watch this. You click on it, and then you stick it right in the middle. It draws the parabola for you. All we got to do, and that's the basic graph for this, what we got to do is come in here and make the moves. So we didn't do a vertical shift. If I did, I would move this. I did a horizontal shift, so I got to move the horizontal shift. We went 10 units to the left, so I got to slide this 10 to the left. So I'm at 9, I'm at 10. So now I'm at negative 10. So I would save that. It's going to move the graph up here to the left like I needed, and then check my answer. Okay, so we're just going to go through these and see what happens. The only one that it won't give you a tool on is the line tool, okay, which is what I got here. G of x equals x minus 5. The basic graph would be y equals x. So what we got to do is see what this minus 5 is doing. So since you're not inside parentheses with the x, it's not going to be horizontal. This just subtracted 5 from the end of the function. So remember, since we're adding and subtracting at the end of a function, it's going to be a vertical. And we said if the b was negative for a vertical, that would move me down. So I need one of these that moves down 5, which would be C. And we start with the graph of y equals x. So you got to know the move, and you got to know what graph they got it from, okay? So we check that. And then move on to the next one, which is graphing it. So this is the only one that you couldn't do with it don't open the box for us. So we physically got to find 2 points and graph this. So I'm going to use, if x is 0, 0 minus 5 would give me a negative 5 for my y. So I'm going to go to 0, negative 5 for my first point. And then I'm going to use a 5 for my x, because if I use a 5 for my x, 5 minus 5 would give me a 0 for my y. So let me go find 5 and 0 and click that. So the line tool is the only one that don't give you the box to pop up, okay? But remember, the y equals x graph used to come up through the middle. but we actually did move it down 5. All right, so check that. Then we're going to the next one. All right, so this one is the y equals 1 over x graph, and they added 3 to the end of it. So since they added the 3 to the end of it, it's going to move it up 3. So we want to go with A. Now watch this. When you check this, they're not going to make us graph this one. They're going to make us choose a picture. So which one of these looks like it went up 3? So that one looks like the basic graph I drew you. B looks like it shifted up 3. And then if you look at C, it looks like it shifted down 3. So mine went up 3, so I would pick my B and then move on. All right, so let's see what's happening here. This looks like the cube because I got a 3 sitting there. Notice it's got a negative in the very front, and we said a negative is going to reflect it across the x-axis. So these two with the y-axis, we can throw them out. And then this is inside parentheses with the x. So that's going to be horizontal. And we said if horizontal was negative, it was going to move me to the right. So I need to reflect across the x and move right 11. So that would be, looks like B. Now this basic graph we drew was what? X to the third. So I'm going to hit my X. All right, let me move this out of my way. And then hit my exponent and put in a 3. And then check my answer. Now this one, we're going to click the graph. Since that's an exponent 3, we want the cube tool. And the cube tool is this little curvy looking line. So click it, and then remember, stick it right in the middle. It's going to draw the curve. We got to go over here and tell what happened. So we did what? We went right 11 units. So that would be horizontal right 11. Whoops. All right, there's 11. And then I reflected across the X. So notice down here, you got 2 options. We reflecting over the X, so we're going to check that. Save our graph, and then check our answers. So they're not bad. I just wanted y'all to get used to being able to use these tools on here. All right, so now this one has sort of like a little boxes they want me to fill in. So let's see. X plus 5 squared plus 1, since I got an exponent of 2 in here, this would actually start with my x to the second. It's my squared graph. Let's see what this one says. Shift it blank 5 units. So the 5 is in here with the x inside the parentheses. So that's going to be a horizontal move. And on horizontals, if it's positive, it's going to move it left 5 units. So you come down here and click left. And then the 1 is being added at the end of the function. So since it's at the end of the function and it's positive, it's going to move it up. So that would be up 1 unit. So just go by them 3 cases we had. Now we're going to have to what? Graph this. So x squareds will be the quadratic tool. So click it and put it right in the center. Now we said we shifted left 5 units. So horizontal will go left to 5. And then we said we're going to shift it up 1 unit, which is vertical, positive 1. So notice it moved me left and up. That was my only moves, so I'm going to save that and check. All right, so this was sort of tricky, but it's telling you you're going to start with the graph of the square root of x. Now, when things are underneath a square root like that, we treat them like they're in parentheses. So since that x minus 3 is inside the radical, it's like it's all inside parentheses, which means I'm attacking that x, which is a horizontal move. So on horizontal, if we subtract 3, we're actually going to move to the right 3 units. So on this one, you had to put it all in there. So write 3 units, click answer. And then they're going to make us graph this. So since they don't have a tool for the square root, they're just going to have us pick one of the pictures. Notice this one, if you started at the middle, it went up 3, so that's not right. Looks like this one went left 3, that's not right. C looks like it went down 3, that's not right. And then D looks like it actually went to the right 3, which is what I needed. So I click on that and check my answer. Oh no, I didn't draw a cube root one, but a cube root one is going to look just like the square root one. It's just going to be a little less steep. It'll sort of be flatter looking. So notice they didn't put the 6 inside the radical though. They added it to the end. And remember, when they add it to the end, it's going to be a vertical up or down. And on vertical, if it's positive, it actually moves it up. So we're going to move that graph up 6 units. And this one will probably give us a picture to pick. So the only difference on the cube is it's got the right side and the left side. Sort of looks like them graphs I drew earlier. But y'all, which one of these went up 6? This one looks like it went down 6, right? B is right through the center like the cubic would go. And then like y'all said, what, C looks like it went up 6. So I'm going to pick C and final check. Oh, did I not click that? All right, y'all, so one more of these. All right, so notice they're telling us you're starting with the graph of x squared, which we knew because of that 2. So now let's see. All right, so let's see what this one's playing with. All right, so first I hit that -7. Remember, when I'm inside the x, in parentheses, I'm on left or right. Since that's negative, it's going to go right 7. Then this one says reflected across the, well, the only thing we're going to reflect because of that negative is the x-axis. In this chapter, you'll never put y-axis. And then shift it. 3 is at the end, so it's going to do my vertical. Since it's positive, it's going to go up 3. All right, then check that answer. And then we'll probably have to graph this. Oh no, that was it on that, and I guess you didn't have to graph it. So we're done with that. So I'm going to quit this share. All right, so what I'm going to do is give you all a 10-minute break, and then we will do 7-4, and 7-4 will be the last thing I do today. But 7-4, I will be showing y'all how to do the quadratic formula. So let's pause and take 10 minutes and go to my screen. All right, so we're going to look at 7.4 now. And that deals with quadratic functions. Now, 7.4, we're only going to look at what we call zeros. So zeros are solutions to quadratic functions. That one in. All right. Zeros are also the place where graphs cross the x-axis. Okay, because remember, if they cross the x-axis, that y value is 0 along that x-axis, okay? All right, so we're going to look at solving the quadratic functions. So solving quadratic functions or finding zeros. Those mean the same thing, okay? So to solve quadratic functions, there's two methods we'll look at. First method is factoring. Okay, to solve by factoring, you want everything on one side equal to 0. And then remember, you would factor it and then set each of them factors equal to 0 before you solved it. Second way I'm going to solve these is by the quadratic formula. And this is what I sent y'all a link for to put in your calculators the other day. Quadratic formula says to find those solutions, we use this formula. Negative b plus or minus the square root of b squared minus 4ac. All of that is over 2 times a. Now, when you start this, it must be in the form, just like factoring, everything on one side equal to 0. So you really got to set them equal to 0 to find the zeros, okay? And I think all year long, the only thing I'll ever set anything equal to basically is these zeros. So if you're weak on factoring, then you want to learn that quadratic formula because it will solve every single quadratic function. Factoring will only solve the ones that you can actually factor, okay? So let me turn over and let's start looking at these. So we're going to find the zeros. And they always put the S in there because it could be 1 0 or more zeros. So I'm telling you, since they're quadratic, they're going to have 2 zeros unless it's a repeating type polynomial, okay? So y'all, my first one is going to be f of a equals a squared plus 11a plus 24. So no matter which method I go, I would take this a squared plus 11a plus 24 and set it equal to 0. So what I check for, since there's not a number in front of the a squared, it's basically a 1. So these ain't too bad. To factor this, you want to see if there's factors of the last number 24 that add to get 11. So 24 could be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So I do have a factor of 24 that adds to get 11, which is 3 and 8. So I could go right into my parentheses on this. Since there's an a squared, you would put an a and an a. Since this 24, the last number is positive, both of these factors will have the same sign as the middle, so they'll both be positive. And then we said the factors of 24 that gave us 11 were 8 and 3, so I can put in my 8 and 3. So that would be factoring it, and then we would take both factors and set them equal to 0. So basically, you'll notice now all you're basically doing is changing the signs. So right here, you would subtract 8 to get the a by itself, so that a equals a negative 8. On the second one, you would subtract 3, so that a equals a negative 3. So your two solutions would be a equals negative 8, comma, negative 3. Which also tells me that if I was to graph this, it would cross over the x-axis at negative 8 and negative 3. Now, if you are weak on your factoring, we're going to do it the other way, which is with the quadratic formula. Okay? So you don't have to do it both ways, but you do got to pick one way or the other. So I would still take it and set it equal to 0. Now to use the quad, you got to figure out what your A is equal, your B is equal, and your C is equal. These are only numbers. So that would be a 1 since there's no number in front of the A squared. B would be 11, and C would be 24. You cannot put variables into the formula, only the numbers. And if you use the calculator program I gave you, only the numbers, no variables. All right, so let's put our formula down. We had negative b plus or minus. Then I had a b squared minus 4 times a times c. All of that was over 2 times my a. So I just used parentheses for those letters real quick. Now I'm going to put in 11 for the b, 11 for that b, 1 for the a, 24 for the c, and then down here was the a, which is 1. So I'm just using that formula I gave y'all on the other side. Now, a lot of work is getting done under the radical. So this just turns into a negative 11 plus or minus. Right here's 11 squared. All right, so let me see. 11, if you square that, would give you 121. Now notice, everything on the right side is getting multiplied. So since I only have one negative, it's going to stay negative. And then I would do 4 times 1 times 24. And that's going to give me what, 96. And then on the very bottom of the whole problem, 2 times 1 is 2. So guess what? The next step, you cannot do nothing on the outside. What we got to do is figure out what 121 minus 96 gives us. So that'll be negative 11 plus or minus square root 121 minus 96 should be what, 25? 25 is under the radical, and then on the bottom is still a 2. All right, so I'm going to bring that up to here to work it now. So now the next step, you got that negative 11 plus or minus. Now, what is the square root of 25? So over here, I could do second x squared to get my radical, put my 25 in, and y'all, the square root of 25 is 5. So you now have negative 11 plus or minus 5 all over 2. Notice, once you take a square root, you got to get rid of the radical if that number comes out of it. So if it's a perfect square like a 25, you get rid of the radical. All right, so here's how you get the 2 answers. First, you got a plus and minus here. So the first time you go through, you add 5 and divide by 2. So negative 11 plus 5 is negative 6 divided by 2. Negative 6 divided by 2 is negative 3, which was one of my answers. And then to get the second answer, you're going to subtract 5. Negative 11 minus 5 divided by 2 would be a negative 16 divided by 2, which is negative 8, which is my second answer. So quadratic formula has a little bit more work, but it will solve everything that you can solve by factoring. Now, the difference is factoring can't solve everything that the quad can, okay? Now, watch this. This is the beauty. I sent y'all that program the other day. Here's what you could do on this problem. Hit program, and all y'all will have is quad. So you would go to your quad, hit enter, and then it wants A. A was 1. B was 11. C was 24. And y'all watch this. When I hit enter, I get negative 3, negative 8. So that's why y'all probably want that program, okay? All right, y'all, number 2. Now, I'm probably not going to work all these both ways. This one has f of x equals x squared minus 14x minus 4. So, could you factor this? Since this is negative, you would need factors of 4 that subtract to get a 14. Hey, that's not happening because the only factors of 4, 1 and 4, they're not giving me 14. 2 and 2, they're not giving me 14. So guess what? You cannot factor this one, so you have to use the quad. Okay, so to use the quad, I'm going to take my x squared minus 14x minus 4 and set it all equal to 0. All right, so let's see. A, there's not a number there, so it's a 1. B is always in the middle, negative 14. And then C is a negative 4. Now, you got to make sure these are in the right order. X squared, X, and then your number, okay? All right, y'all, so here we go. X equals negative B plus or minus the square root B squared minus 4 times A times C. All that's over 2 times A. All right, so B was a negative 14, so the negative and the negative 14 are going to make that positive. Negative 14, when you square any negative, it's going to be positive. Now, so that B squared will never stay negative, okay? So if you got a negative number, you doing it on the calculator, you better put it in parentheses. All right, A was 1, C was negative 4, A was 1. All right, so here we go. The negative makes that a positive 14 plus or minus negative 14 squared is 196. Now y'all look over here. You got a negative and another negative. Since all this is being multiplied, those two negatives will make that a positive. And then let's see, 4 times 1 is 4, times 4 is 16. All of that over 2 times 1, which is 2. All right, so now you're done on the outside until we get this radical taken care of. So the 14 plus or minus square root 196 will add to 16 and give me 212. All of that over 2. So what I need to do now is simplify that square root of 212. So let's work on that on the side here. So this will be my side work. Let's simplify that square root of 212. So to simplify a radical, it cannot have any factors that are 4, 9s, 16s. I'm writing what we call perfect squares on the side here. Oh, what's next? 100. Oh, 11 times 11 would be 121, and I'll even go to 12 times 12, which is 144. So this 212 cannot have any of these factors in it, or it's not considered simplified. Simplifying a radical means you got to pull out any perfect square factors. So what I'm going to do is just start dividing that 212 and see if I get nice numbers. So 212 divided by 4 would give me 53, which is not a decimal. So I know it has a, so, and y'all look, 53 does not look like it has any more of these numbers in it, right? 53 won't divide by 4, it won't divide by 9, 16, it won't divide by 25, everything else is getting too big. So what we'll do is rewrite that square root of 212 as the 4 times 53. So 4 times 53 still equal 212, but y'all, the reason you had to do that was because this factor has a square root now. Square root of 4 would make that a 2, and then bring down the square root of 53. Now, since this 53 does not have any more factors that are perfect squares over here, it is now simplified. So this will now turn into a 14 plus or minus 2 square root of 53 all over 2. Now, the final step to simplifying this, all 3 of the outside numbers have to reduce if you're going to reduce it. So 14, 2, and 2 all divide by 2, so that gives me a 7 plus or minus 1 square root of 53 all over 1. So remember, I don't have to write that 1, and I don't have to write the 1 on the bottom. But had the 7 turned into a 1, I would have had to write it there, okay? So it's understood to be a 1 here and a 1 on the bottom. Now y'all watch this. Program. Because if you don't like simplifying radicals, this calculator don't mind. A was what? 1. B was a negative 14. And C was a negative 4. Now watch, the calculator first will give you decimals, but I don't want decimals. I want these radical answers. So when I hit enter one more time, there's my 7 plus square root of 53, 7 minus square root of 53. So that's the 2 answers. We're just writing it shorthand since they both had the radical. Anytime I got radicals, I write them shorthand. Now, if the radical went away like it did a while ago, then I would have actually figured out my 2 answers, okay? So Quadratic formula is tricky, but it's not bad once you get used to it. I think the hardest work is doing that simplifying right there, okay? All right, so let's try the next one and see what we do. Three has x squared plus 7x minus 5 equals 0. So they already had this one set up for 0 for me. So let me see if I'm going to be able to factor this. I need factors of 5 that subtract and get 7. Well, y'all, the only factors of 5 are 1 and 5, and there's no way you're getting a 7 out of that. So we got to use the quad. So basically, you see this chapter is getting us good on the quad, right? So A is 1, B is 7, and C will be a -5. All right, and here we go. X equals -b plus or minus square root b squared minus 4 times a times c all over 2 times my a. All right, so b was 7. That's going to go there and there. A was 1. That'll go there and there. And then C was -5. All right, y'all, we got everything plugged in. Here we go. A negative times a positive is going to make that a -7. Plus or minus square root. 7 squared is 7 times 7 is 49. And then let's see, we got 2 negatives over here. So since I got 2 negatives, that's going to make that a positive. And then let's see, 4 times 1 is 4, times 5 is 20. All that's over 2. All right, y'all, so now we got to add under the radical because we can't do anything else on the outside. So I get -7 plus or minus square root. Oh, let's see, 49 and 20 is 69. All that's over 2. So notice now I'm at the point where I got to simplify that radical. So I'm going to go up here and do my side work. Square root of 69, and remember I need to see if it'll divide by these perfect squares. Ooh, I think that's big enough because 64, anything else will be bigger. So will 69 divide by 4? No. 69 divided by 9? No. Divided by 16? No. 25? No. So 69 is not going to divide by any of these numbers. So this one does not simplify, which means that would be my final answer. Because y'all, if the radical don't simplify, you will never have a number out front that can simplify with these other ones, okay? All right, so let's see, moving on. This one has f of x equals 3x squared minus an x plus a 4. All right, so first thing we'll do is set it equal to 0. All right, so let's see. If we was going to factor this, on this one, you would have to multiply 3 times 4 and get 12. Do factors of 12 add to get 1? That would definitely be a no. They subtract to get 1, but they do not add to get 1. So this one does not factor, so we must use the quad. And y'all, these are getting radical answers, and there's no way you're going to factor this stuff with radicals, right? All right, so let's see. A is 3. B is a -1. So remember, anytime the number's not there, it is definitely a 1. And then C would be a +4. All right, so here we go. Negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, so b was -1. That goes there and there. A was 3. It goes there and there. And then c was a 4. All right, so let's see what happens. Negative times negative makes that a positive 1. Plus or minus square root -1 times -1 is 1. Now y'all look at this side. It's only got one negative, so it's going to stay negative. And let's see what we get. 4 times 3 is 12. 12 times 4 is 48. All of that's over 2 times 3, which is 6. All right, so let's do the subtraction. So I get 1 plus or minus square root. 1 minus 48 is a -47. All of this over 6. So let's pull that up. So what we got to do is try to simplify that square root of -47. So this is our side work. Now, first thing, you cannot leave that negative under that radical. So remember, the first thing I would do to that would make that a square root of -1 times my square root of 47. Remember, if you got a negative, you got to bring it out because that square root of -1 is going to be replaced with the I, which means it's imaginary. In the real world, we cannot take the square roots of a negative number. And y'all, if you don't believe me, second square root -47, enter, non-real answer, which means it's imaginary. So bring the negative out, replace it with the I, and then let's check this 47. 47 will not divide by 4. It won't divide by 9. It won't divide by 16. Everything else is starting to get too big. So it will not. So the 47 stays under the radical. But you cannot leave a negative under a radical. So that simplified to 1 plus or minus I square root of 47 all over 6. So that's like a 1i, okay? So calculator does that. Let me clear that. Program, go to my quad, enter. So my 3 numbers were 3, -1, and 4. So I get 1 plus I squared of 47 over 6, and then 1 minus I squared of 47 over 6. This program was written a long time ago, so it don't use the pretty little fancy I. It just uses a capital I on that, okay? But remember, that is really a little bitty little I, okay? All right, y'all, so this would be my final answer since I couldn't simplify that radical 47 any further. I think I just got a couple more of these for you. All right, 5 has a 5x squared minus 7x minus 3 equals 0. All right, so I'm not even going to try to factor it because I'm pretty sure it don't. So let's just go A equals 5, B equals -7, and C equals -3. Oh, no, hang on. I didn't see that on that. I'm going to go back to number 4 real quick. I'm going to go back to number 4 real quick because I just seen something. They want these in the form of A plus BI, which means they sort of want me to separate it. So to separate it, you're just going to put each part over the 6. So that would be 1 over 6 plus or minus I square root of 47 over 6. Oh, I'm getting all messed up. So that's not a negative. So they both have to be put over the 6 and split into 2. And this is the A part and this is the BI part. So if you get imaginary answers, they want it split apart into the 2 parts, okay? Now, the calculator don't split them apart. If you use it, you physically got to do that, okay? All right, so now let's get 5. All right, so let's make our radical. We know x will equal negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. So we need a negative 7 for the b, 5 for the a, and then a negative 3 for the c. All right, y'all, so that negative times negative makes that a positive 7. So whatever you start out with, that negative is always going to change it. All right, let's see, under the radical, negative 7 times negative 7 is 49. Let's see, I got 2 negatives over here, so that's going to be positive. 4 times 5 is 20. 20 times 3 is 60. All of that's over 2 times 5, which is 10. All right, now remember, nothing else we can do on the outside, so we got to add under the radical. So 7 plus or minus a square root. 49 plus 60 is 109. All of that over 10. So here we go, side work on that radical. Square root of 109. Now this time I do not have to worry about bringing out a negative to make it imaginary. So let's see, 109 will not divide by 4. It will not divide by the 9. It won't divide by 16. It won't divide by 25. What's next? It won't divide by 36. It's not dividing by 49. And then everything else is getting so big. So this one does not simplify. So your final answer is 7 plus or minus square root of 109 over 10. Now, I will say, you don't have to download that calculator program if y'all like doing these by hand. They're not too bad, right? All right, here we go. F of x is a 3x squared minus 7x minus 11. All right, so I'm pretty sure this one's not going to factor. So I know A is going to be 3, B is going to be negative 7, and C is a negative 11. All right, negative B plus or minus a square root B squared minus 4 times A times C, and all that's over 2 times A. All right, so let's put a negative 7 here and here. A was what? 3 and 3, and then C was negative 11. All right, y'all, here we go. Negative times negative makes that a positive 7. Plus or minus, negative 7 we said was what, 49? This side has 2 negatives, so that's going to make that positive. Ooh, let's see what we get. 4 times 3 is 12. 12 times 11 is 132. All of that over 2 times 3, which is 6. Now, I will say, let me finish this one. When you put this in MATLAB, I'll show you. Let's see. Let's add 49 and 132. I get what? 181. All of that's over 6. All right, so side work on the radical. That is a square root of 181. I know it won't divide by 4, so I'll check 9. Nope, I get a decimal. It's not going to divide by 16 because it's odd. 25, no. 36. I'll try that one real quick. No, that's not even. 49. Nope, so notice that thing's not going to divide by any of these numbers, which means that will not simplify. And since that will not simplify, this will be my final answer. So let me tell you, if I was putting this in MATLABs, first thing I would hit would be the fraction bar. Then I would come up and I would do my 7 plus or minus. Then I would hit my radical, put in my 181, and then arrow to the bottom and put in your 6. Okay, you got to make sure that if you do the top first, it'll put everything up under that radical funny instead of making it look like the big fraction y'all need, okay? And then since this one wasn't imaginary, I didn't have to worry about splitting it up. All right, y'all, so that takes us through 7.4. So I'm going to stop sharing and turn the video off.